What if I told you that 10 million years ago, our ancestors were already showing the first signs of what would become humanity's greatest advantage, the ability to hunt in coordinated groups and gather resources systematically? This was long before stone tools, before fire, even before we walked upright. Yet these ancient creatures were developing behaviors that would eventually separate us from every other species on Earth. If you're fascinated by human evolution like I am, make sure to hit that subscribe button and turn on notifications, because we're about to discover how the first hunters and gatherers laid the foundation for human civilization. Welcome back. Today we're traveling to the Middle Miocene epoch, 10 million years ago, when Earth was a dramatically different planet and our ancestors were taking their first steps toward becoming the ultimate predators and resource managers. This period represents a crucial turning point where ape-like creatures began developing the collaborative behaviors that would eventually make humans the dominant species. In this video, we'll explore how our ancient relatives survived in a world filled with massive predators, how they developed the first cooperative hunting strategies, and what archaeological evidence tells us about their early gathering techniques. We'll also examine the environmental pressures that forced these developments and discover why this period was so critical for human evolution. What makes this era particularly fascinating is that we're witnessing the birth of behaviors that still define us today. The teamwork, resource planning, and social coordination that built modern civilization all have their roots in this ancient period. Stay with me as we uncover the secrets of our first hunting and gathering ancestors. Let me paint the picture of Earth 10 million years ago during the Middle Miocene. Global temperatures were 3 to 4 degrees warmer than today, creating a greenhouse world with no permanent ice caps at either pole. Sea levels were significantly higher, and the geography of continents was notably different from what we see today. Africa, where our story unfolds, was a vast mosaic of dense tropical forests, woodland, savannas, and large freshwater lake systems. The continent was more fragmented, with extensive seaways and inland seas creating isolated habitats that drove evolutionary innovation. Climate was generally stable and humid, supporting incredible biodiversity. During this period, our ancestors belonged to various species of Miocene apes, the most relevant being members of the Dryopithecine family. The most important fossil evidence comes from sites like Rudabonia in Hungary, where David Begun discovered Rudopithecus hungaricus, and from African sites yielding Proconsul and Afropithecus fossils. Proconsul, discovered by Mary Leakey in 1948 on Rusinga Island in Lake Victoria, represents one of our best windows into this period. These creatures, dating from 23 to 14 million years ago, show a fascinating mix of monkey and ape characteristics. They were roughly the size of modern chimpanzees, but had longer limbs and more flexible spines. Geological evidence shows that the East African rift system was actively forming during this time, creating the diverse topography that would later become crucial for human evolution. Volcanic activity was intense, creating mineral-rich soils that supported lush vegetation and diverse animal communities. The fossil record reveals an extraordinary array of Miocene fauna. Giant pigs like Cubanocoerus, early elephants called Gomphotherium, primitive giraffes, and massive carnivores like Amphicyon, the bear dog, dominated the landscape. This was a world where our small ancestors had to compete with some of the most formidable predators in Earth's history. Carbon isotope studies of ancient soils indicate that forest environments were more extensive than previously thought, but with significant patches of more open woodland. This mosaic environment created the perfect evolutionary laboratory for developing new survival strategies. Recent discoveries at sites like Napak in Uganda have revealed fossilized tools that may represent some of the earliest evidence of systematic resource processing, though dating and attribution remain controversial among researchers. Here's where our understanding becomes both fascinating and frustrating. The evidence for early hunting and gathering behaviors 10 million years ago is largely circumstantial, but several lines of research are painting an intriguing picture. The first major question is whether our Miocene ancestors were actually hunting or simply scavenging. Traditional views suggested early apes were primarily fruit eaters, but recent dental analysis tells a different story. Microwear patterns on fossil teeth from proconsul and related species show evidence of processing tough plant materials and possibly meat. Dr. Peter Andrews' research at the Natural History Museum in London has identified cut marks on animal bones from Middle Miocene sites that suggest systematic carcass processing. However, the debate continues over whether these marks were made by early hominids or other animals. The mystery deepens when we examine social organization. Modern great apes show remarkably sophisticated cooperation in certain contexts. Chimpanzees engage in coordinated hunting of smaller mammals, using complex strategies that require planning and communication. If our 10-million-year-old ancestors had similar capabilities, it would revolutionize our understanding of early human evolution. Recent studies by Dr. Jill Proutz on chimpanzee tool use in Senegal have documented behaviors that were previously thought impossible. Chimpanzees fashion spears to hunt small mammals, use stone hammers to crack nuts, and even engage in coordinated group hunts that require individual specialization. If these behaviors exist in modern apes, what were their ancestors capable of? Archaeological evidence from this period is frustratingly sparse. Stone tool technology clearly hadn't developed yet, but that doesn't mean our ancestors weren't using organic tools that don't preserve well in the fossil record. Wood, bone, and plant fiber implements could have been extensively used without leaving clear archaeological signatures. The gathering aspect presents its own puzzles. Modern great apes show remarkable knowledge of seasonal resource availability, traveling long distances to exploit specific food sources at optimal times. This suggests sophisticated environmental knowledge and planning abilities that could have roots stretching back 10 million years. Climate analysis shows that this period experienced significant environmental fluctuations, which may have driven the development of flexible foraging strategies. Groups that could adapt their hunting and gathering techniques to changing conditions would have had significant survival advantages. Now, let's examine the scientific theories that attempt to explain how hunting and gathering behaviors might have emerged during this crucial period. The woodland mosaic theory, developed by researchers like Elizabeth Verber, suggests that fragmented forest environments created ideal conditions for developing flexible foraging strategies. Groups needed to exploit both arboreal and terrestrial resources, leading to increasingly sophisticated resource management. Evidence supporting this comes from paleoenvironmental reconstructions showing that Middle Miocene Africa contained extensive ecotones boundary areas between different habitats that typically support high biodiversity and require complex foraging strategies to exploit effectively. The predator-pressure hypothesis proposes that intense predation from large carnivores forced early apes to develop cooperative defense strategies that later evolved into coordinated hunting. The Middle Miocene fossil record shows abundant large predators, including early saber-toothed cats and massive hyenas that would have posed serious threats to our ancestors. Dr. Craig, Stanford's research on modern chimpanzee hunting behavior provides insights into how this transition might have occurred. He documents that successful hunts often require individuals to play specialized roles: drivers, blockers, and ambushers. This level of coordination suggests cognitive abilities that may have much deeper evolutionary roots. The resource, competition. Theory suggests that increasing competition for high-quality food resources drove the development of more efficient gathering techniques. As forests became more fragmented and competition intensified, groups that could systematically exploit resources had advantages over those using random foraging strategies. Isotope analysis of Miocene. Mammal teeth shows evidence of dietary specialization and niche partitioning, suggesting that our ancestors were developing specific ecological roles that required sophisticated resource knowledge. The tool readiness hypothesis, proposed by researchers studying modern ape behavior, suggests that the cognitive and physical capabilities for tool use were present millions of years before the first stone tools appear in the archaeological record. Our 10-million-year-old ancestors may have been using extensive organic toolkits that simply don't preserve. Recent experiments by Dr. Susanna Carvalho with wild chimpanzees have shown that apes can quickly learn to use stone tools when the materials are available, suggesting that technological capability may have existed long before it was expressed in durable materials. The social learning theory emphasizes that hunting and gathering strategies require cultural transmission across generations. The development of teaching behaviors and social learning mechanisms may have been crucial innovations during this period, setting the stage for the cumulative cultural evolution that would later characterize human societies. Modern studies of great ape learning show that young animals spend years learning foraging techniques from adults, and there's evidence that different populations develop distinct cultural traditions. This suggests that protocultural learning systems were operating 10 million years ago. Genetic evidence provides additional support for early behavioral complexity. Recent analysis of great ape genomes has identified genes associated with social cooperation and learning that show evidence of positive selection in the lineage leading to humans, suggesting these traits were being refined millions of years earlier than previously thought. To summarize, life 10 million years ago represents a pivotal moment when our ancestors were developing the behavioral foundations that would eventually make humans the most successful hunters and gatherers in planetary history. These ancient apes lived in a world of abundance and danger, where survival required increasingly sophisticated strategies for obtaining food and avoiding predators. The evidence suggests that coordinated hunting and systematic gathering may have much deeper evolutionary roots than traditionally assumed. While we lack direct proof of complex behaviors from this period, the combination of environmental pressures, anatomical capabilities, and modern ape behavior studies paints a compelling picture of our ancestors as remarkably capable problem solvers. These early developments set the stage for everything that followed. The social cooperation required for group hunting became the foundation for complex human societies. The environmental knowledge needed for efficient gathering evolved into our species' remarkable ability to adapt to any ecosystem on Earth. The communication systems that coordinated these activities eventually gave rise to human language. Understanding this period helps us appreciate that human exceptionalism didn't appear suddenly. Instead, it represents the culmination of behavioral innovations that began millions of years ago, when our tree-dwelling ancestors first began working together to survive in an increasingly challenging world. The mysteries surrounding this period remind us how much we still don't know about our deep evolutionary history. Were our 10-million-year-old ancestors more sophisticated than we imagine? Did they possess cultural traditions and technological capabilities that we simply cannot detect in the fossil record? What do you think was the most important innovation that allowed our ancient ancestors to become successful hunters and gatherers? Was it social cooperation, environmental knowledge, or early tool use? Let me know in the comments below. The story of our evolutionary past continues to unfold with each new discovery, and there's still so much more to explore about how we became the remarkable species we are today. If you found this journey through deep time as fascinating as I do, give this video a thumbs up and share it with someone who loves learning about human origins. Until next time, remember that the cooperative spirit that built human civilization has roots stretching back millions of years to our first hunting and gathering ancestors.